In today's video, we show that this integral value is equal to 2 pi by 1 minus p square where 0 less than p less than 1 using residue theorem. So, in order to integrate this, substitute z is equal to e raised to I theta. And this integration is from 0 to 2 pi, so that this is mod z is equal to 1, that is unit circle is this. So, z is equal to e raised to I theta. And dz is equal to integrate with respect to theta, e raised to I theta I d theta into integration derivative of this function, that is I d theta. So d theta is equal to dz divided by I d e raised to I theta. That means dz divided by I e raised to I theta is z. Dz divided by Iz. And we also know that sin theta is equal to e raised to I theta minus e raised to I minus I theta divided by 2i. If it is cos theta, we can substitute e raised to I theta plus e raised to minus I theta by 2 for cos theta. This is for sin theta. Substitute this value. This is integral 0 to 2 pi means mod z is equal to integral over mod z equal to 1 by 1 minus 2p sin theta is, we can substitute e raised to I theta z minus, this is 1 by z e raised to minus I theta 1 by z divided by 2i. So 2p into z minus 1 by z divided by 2i plus p square. And d theta is dz by Iz. So dz by Iz. Now this is equal to integral over mod z equal to 1 dz divided by Iz minus 2 cancel. Multiply with this Iz, I also cancel, I cancel. And remaining is pz minus pz into z, that means pz square, and minus plus p by z into z means plus p, and here is p square into Iz. We multiply Iz with this denominator, so Iz minus pz square plus p square Iz. Now we need to find the singularity of this function, so just simplify this function as dz divided by, take Iz common. So we get Iz. So we get 1 minus pz, also we take Iz common. So 1 by I is that, plus p into 1 plus p Iz. Oh, just simplify again, dz divided by, this is Iz, is 1 minus, 1 by I is minus I. If we conjugate, multiply with this conjugate, 1 by I is minus I. So this is 1 plus I pz plus p into 1 plus, this is also I pz. So we can write it as integral over mod z equal to 1 dz divided by 1 plus I pz is common and remaining is Iz plus p. Iz plus p. So we can write this function as this. So this is clear that denominator is 0 when 1 plus I pz is equal to 0. That means 1 plus I pz equal to 0 means I pz equal to minus 1, z is equal to minus 1 by I p. that is 1 by I is minus I, also here is minus, so minus minus plus I by P. So Z is equal to I by P is one of our singularity, and other is when I Z plus P equal to 0. 0. So I Z is equal to minus P and Z is equal to minus P by I. 1 by I again minus I and minus minus plus, this is IP. So Z is equal to IP and I by P are singularities of this function, and these are symbol poles. Clearly these are symbol poles, zeros of one order for both. So these are symbol poles. So we know that the residue theorem is, we get the integral as integral mod Z equal to 1 dz divided by 1 plus IPZ into IZ plus P. So this is equal to, we know that by residue theorem, this is equal to 2 pi I into sum of the residues inside the circle. So residue at Z is equal to singularity f of Z, and sum of the residue at the singularities. So here we have two symbol poles, Z is equal to I by P and Z is equal to IP. These are symbol poles of the function f of Z, I by P and IP. And in question we have given 0 less than P less than 1. So IP is clearly an imaginary number, pure imaginary number. 0 less than P less than 1. So P is between 0 and 1, and I into P is, this is I and this is 0. I into P is between this. So this is our unit circle. So IP is inside the circle. But I by P, if P less than 1, 1 by P is greater than 1. So 1 by P into I is outside the circle. 1 by P into I is outside the circle, somewhere here. So IP is inside the circle. So singularity inside the circle is Z is equal to IP. That means 2 pi I. This integral is equal to 2 pi I into residue at Z is equal to IP f of Z. This is our f of Z. Now this is equal to 2 pi I into residue at a symbol pole. We have the formula, residue at a symbol pole is limit Z tends to singularity IP Z minus IP into f of Z. This is the formula for residue at a symbol pole. Now this is equal to, we can write it as f of Z is 1 by, that means 2 pi I into limit Z tends to IP Z minus IP into f of Z is 1 by 1 plus IPZ, and this is IZ plus P. IZ plus P. We can write it as 2 pi I into limit Z tends to IP Z minus IP into 1 by 1 plus IPZ into, take I outside, so that this is Z minus IP. I into I square is minus 1, minus minus plus. So when we take I outside, we multiply it with the minus I. That means 1 by I. So Z minus IP. So this is cancelled. Now applying the limit, we get, here is 1 by I into 1 by 1 plus IP substitute ip for z into ip. That is, we get I cancel, 2 pi into 1 by 1, I square is minus 1, p square, that means 1 minus p square. 2 pi divided by 1 minus p square is the value of integral by residue theorem.